we supposed to be deviating from that horizontal that we set? It's a rigid plane.
No, we're maintaining a certain level above the ground. Now, there are devices on the attitude indicator called pendulous vanes. And using the pendulous vanes and the vector of gravity, it does keep that so that it's horizontal to the ground.
Actually, it uses INS, which is
That's an INS. That's not an attitude indicator. That's INS.
INS uses for the correction of magnetic.
No, that's not what an INS does. An INS consists of three sets of gyroscopes set at 90 degrees to each other that look at a coordinate system on the Earth. So one way that you can easily look at that is if you take a box. I don't think I have a box handy real quick. Just double check. No, I don't see one. Well, here, we'll use this. So here's a box. Now this box has got a coordinate system in it. It's got a height, it's got a width, and it's got a length. So you can set up XYZ coordinates on this box. Take that, put it in the box. You can describe every point on the surface of this in those XYZ coordinate system. And what an INS does is it takes three sets of gyros and it spins up on the ground, and then it keeps track of your position in that three-dimensional space. And then it coordinates that with the surface geode of the Earth, the WSG 84. So that will tell you where you are at all times.
It uses magnetic. It doesn't use WGS. It uses magnetic north.
So
okay.
If you want to try and move on to something else or want to put up something to support your position, I'm happy to look at it.
INS refers to the latitude and longitude and altitude being fed from the IRU, other systems reference, or selected display pilot of the electronic flight instrument system, EFIS. So it's making the corrections based on already set measurements. Correct?
Sorry, Bob, go ahead.
All right, so go ahead and tell me exactly what that's talking about. What is the electronic flight system?
It's talking about the correction based on the precession that the gyros give.
All right, what is the electronic flight system that you highlighted?
IRS.
No, read it. Click on it and read it.
I've already gone out of it, but it doesn't matter. The point is you're trying to...
Well, yeah, it does matter because I'm asking you about it. Show me.
You brought up the INS and that it was affected by magnetism, that it seeks magnetic north. And then when bringing up a citation about the INS, you read the citation. It doesn't mention magnetism. When asked what that citation means, you couldn't say. When asked what the citation was about, you say the IRS, not the INS. And then say that that's not the point, when the whole point was you bringing up this citation to back you up. Because you brought up the INS. And this citation was meant to back up your claim about the INS. Yet it didn't do that, so therefore, now it's no longer the point. Why bring it up then, Flatzoid? We can see that you like to cite Skybury Aero. And this was the gyromagnetic compass that you tried to strawman Bob with. So being as you like Skybury Aero as a citation you accept, let's take a look. So from Skybury Aero, we can see if the heading is known, then the velocity detected by the INS will determine the local latitude. If the latitude is known, then by detecting the Earth's rotation, the system is able to align with true north. Not magnetic north, true north.
So that will tell you where you are at all times.
It uses magnetic. It doesn't use WGS. It uses magnetic north.
You don't know what you're talking about, do you?
That's not an attitude indicator. That's INS.
INS uses for the correction of magnetic.
No, that's not what an INS does.